Okay, 7th grade, this is our third video on lesson 6.1 on algebraic expressions. In this video, we'll talk about the 6.1 packet, page 4, 5, and 6. Okay, so on page 4 of your packet, you have, looks like this. For numbers 1 and 2, number 1, you need to distribute that 6 to the a in the negative 2, all right, but not to the negative 6. You won't do anything with that negative 6 until after you distribute. Number 2, combine like terms, add up all your w terms. Number 3, I'll do on the board. Okay, so I have 8 minus 6w plus 3w squared plus 2w plus 6 minus 2w squared. Remember, for terms to be like terms, they must have two things in common. They must have the same variable and the same exponent. Here I'm going to start with my highest exponent, which is 2. I have a positive 3w squared and a negative 2w squared. Okay, so I'm going to use shapes to show that these are like terms. I put them both in boxes, okay? Then I add their coefficients. Remember that the coefficient is the number in front of the letter, the number being multiplied by the variable. So here the coefficient is 3, here the coefficient is negative 2. I need to add those together. 3 plus negative 2 is the same as 3 minus 2, which is 1. So I have 1w squared, 1w squared. The variable w stays the same and the exponent 2 stays the same. Remember, in algebra, whenever the coefficient is 1, it's not needed. It's not necessary. We don't need to write it. So if I take that away, 1w squared is the same thing as w squared. So I'm going to leave it like that because this is how you will see it. After my squared terms, I'm going to look for, do I have any w to the first terms? And I do. I have like terms here. I have negative 6w and positive 2w. I'm going to put those in circles to show their like terms. So I need to add those together. Negative 6 plus 2 is going to give me negative 4. So I put minus 4 because this minus sign functions as a subtraction sign and as a negative sign. So it's negative 4w to the first. And remember, when the exponent is 1, we don't write the exponent. It's just understood to be 1. So I have w squared, I have w, and then now I add my constants. Remember, constants are those terms that have no variable. So here that is 8 and positive 6. I add 8 plus 6 to get 14. Since 14 is positive, I put a plus 14 because this means positive 14. And this is my simplified expression. This would be my answer for number 3. W squared minus 4w plus 14. Notice how this expression is written with the exponents going in descending order. It starts from my highest exponent 2, and then 1, and then no variable with an exponent on the 14 since it's a constant. The constant is the last term written in the expression. Number 4, you have negative 2x plus 10 minus negative 7 times x. Okay, here, this right here, if you have minus and negative, remember that's the same thing as addition, because I want the opposite of negative 7. The opposite of negative 7 would be positive 7. So if I rewrite this, making this a plus sign, negative 2x plus 10 minus negative, I could say slash slash. That becomes a positive 7 times x, or 7x. Now I simplify by adding like terms. I'm going to add my x to the first terms, which would be negative 2 x and 7x. Those both have variable x and exponent 1. If I add negative 2 plus 7, that's going to give you positive 5. So I just write 5x, and I'm left with a constant 10. So 5x plus 10 is my simplified expression. Remember that I cannot add these together because 5 has an x in it and 10 has no x. So those are unlike terms, and you can't add unlike terms. The terms must be like for you to add them. Last one we'll do on page 4 is number 9. This is 3 times v minus 6 minus 3. So whenever you have a number written next to a set of parentheses, that means multiplication. So I'm going to multiply 3 times both of the terms inside the parentheses. To show that I'm doing that, I'm going to use what we call the rainbow. Right? 3 times v, I'll write as 3.v, 3 times v. And then I have 3 times the second term, which is negative 6. Remember, that negative sign or that minus sign means negative. So that 3, that positive 3, is being multiplied by a negative 6. 3 times v is 3v, and 3 times negative 6 is negative 18. So I put minus 18. And that's my simplified expression, 3v minus 18. Actually, no, that's not my simplified expression. Why? Well, I still have this negative 3 right here. So after I distribute, I need to add that on to the end. Okay, I distribute the 3 times the v and the negative 6, which I showed here. And then I have minus 3. So here my like terms are both constants. Here I have negative 18, which is a constant, and negative 3, which is a constant. If I add negative 18 plus negative 3, I get negative 21. So my final simplified expression is 3v minus 21. That's my answer. Okay, turn to page 5 in your packet. On page 5, you are translating algebraic expressions. You're translating algebraic expressions, verbal phrases into algebraic expressions. We'll do 3 on this page, on page 5. Starting with number 4. Number 4 reads like this: 1/6 of the sum of W and 7. Okay, there is a couple key words in that verbal sentence which should stand out to you. The first one is sum. Whenever you see the word sum, you should think the answer to an addition problem. So you want the sum of W and 7. So if I want the sum of W and 7, I need to add them together. W plus 7. Okay, but it says I want 1/6 of that sum. 1/6 of the sum. In algebra, in mathematical terms, if you see the word of means multiply. It means multiplication. So if you want 1/6 of this, that means you want 1/6 times this. So to show that, I'm going to put this sum, W and 7, in parentheses, and I'll put 1/6 out in front. Because remember, if you write a number next to a set of parentheses, that's multiplication. So this right here would give me 1/6 of W plus 7, of the sum of W and 7. Number 5, the verbal sentence reads like this: the sum of 1/3 of S, 1/6 of D, and 8. So again, in number 5, they want the sum. So basically, we're going to add up those 3 terms together to get the sum. So what is 1/3 of S? Well, if you take 1/3 of S, remember of means multiply, I need 1/3 times S, which I can just write an S next to the 1/3. I don't need a dot. I don't need to put the S in parentheses. I'm not going to use an X for a multiplication symbol. I just write 1/3 next to an S, and that means 1/3 times S, or 1/3 of S. So I have 1/3 of S, then 1/6 of D, and I'm going to put plus, because remember I'm finding the sum, or the answer to an addition problem. I need 1/6 of D. So I put D next to 1/6, and this means 1/6 times D, or 1/6 of D. So I have 1/3 S plus 1/6 D, and then plus 8. And that will give me the sum of those 3 terms. It will give me the sum of 1/3 of S, 1/6 of D, and 8. Finally, we'll do number 9. Number 9 says this: 1/2 of the sum of 8 and B plus the product of 2 and F. Okay, so again, we're dealing with a sum right here. We have the sum of 8 and B. So 8 plus B, there's the sum of 8 and B. But you want 1/2 of that. If I want 1/2 of that, again, of means multiplication, I need to multiply this times 1/2. So this is going to be 1/2 of that, or 1/2 times that. But I'm going to add this, because it says plus 1/2 of 8 and B plus the product. That should ring some bells in our head. Product means answer to a multiplication problem. So I'm thinking multiplication here, the product of 2 and F. If I want the product of 2 and F, I write 2 times F. And again, in algebra, we just write 2 next to the variable F. There's no need for a dot or parentheses or the X for the multiplication symbol. We just write 2F, and that means 2 times F, which gives you the product of 2 and F. Alright, so that's page 5. You should complete the rest of those. Finally, we'll talk about page 6. So go to page 6. I'll do 3 examples from there. Numbers 2, 3, and 10. 2, 3, and 10. Just by looking at this problem number 2, I see a set of parentheses with a number written right next to it. That tells me right away that I need to use the distributive property to multiply 3 times both of those terms inside the parentheses. So I'm going to show the rainbow in order to do that. I have 3 times 6 plus 3, since it's a positive 3, plus 3 times m. Now what do I do with these 5m and negative 12 term? Well, I don't distribute the 3 to it because those terms are not inside the parentheses, they're outside. So all that I do is just bring them down. Plus 5m minus 12. Okay? Now I need to multiply these terms. 3 times 6 is 18. 3 times m is just 3m. Then I have plus 5m minus 12. Okay, now I can combine like terms. I see that my variable is m. I'm going to combine all my m to the first terms. I have 2 that are like. That is 3m and 5m. 3m plus 5m gives me 8m. Now I add my constants. I have 18 and negative 12, or 18 minus 12, which is 6. So I'm going to put plus 6 because it's a positive 6. And that would be my simplified expression. Remember, you can't add those because those are unlike terms. Number 3, I have 6y cubed plus 15 minus 2 times 4y cubed plus 6. Now in number 3 you have this term, which is negative 2. Remember that sign in front of the term, in front of the number, needs to go with the number. So this is a negative 2 being distributed to both of those terms. Now these terms, 6y cubed plus 15, I'm not going to do anything with those until after I distribute. So all I'm going to do is bring those down. 6y cubed plus 15. Just bring them down to the next line. I need to distribute this negative 2 to both the 4y cubed and the positive 6. So I have negative 2 times 4y cubed and negative 2, so I put minus 2, negative 2 times 6. If I multiply those, again, I just bring those terms down because I have to multiply before I can add. So I have 6y cubed plus 15. Here I have negative 2 times 4y cubed. Well, negative 2 times 4 is negative 8, and the variable y and the exponent 3 stay the same. So it's negative 8y cubed. Here I have negative 2 times 6. Negative 2 times 6 is negative 12. Okay? Now I can combine my like terms. I have 2 y cubed terms. I have 6y cubed, which I'll put in a box, and negative 8y cubed. I can add those together because they have the same variable y and the same exponent 3. 6y cubed minus 8y cubed, 6 minus 8 is negative 2. My variable y stays the same and the exponent 3 stays the same. Okay, I have 2 terms left. They're both constants, so those are like terms. This is positive 15 and negative 12. 15 plus negative 12 is the same as 15 minus 12, which is positive 3. So I put plus 3, and that's my simplified expression, 2y cubed plus 3. The last one that I'll do on page 6 is number 10. Okay, number 10 looks like this. I have negative k plus 1, or I could read that as the opposite of k plus 1, minus 6k plus 8. Okay, I have a negative sign written right next to a set of parentheses. There is a number right there that I need to distribute to k and 1, and that number is 1, negative 1. Remember, if the 1 is not written there, that 1 is there. It's understood to be, in this case, negative 1, since there's a negative sign. So let's distribute. I have negative 1 times k, which will give me negative 1k, or just negative k. If I distribute the negative 1 to this one, negative 1 times 1 is negative 1. And then I have those terms, negative 6k plus 8, which I just bring down since they're outside the parentheses. So negative 6k plus 8. Now I can combine like terms. I have negative k and negative 6k. Negative 1 and negative 6 is negative 7k. And then I have my constants, negative 1 and 8. Negative 1 plus 8 is positive 1. So that's my simplified expression, negative 7k plus 1. Remember to complete pages 4 through 6 due tomorrow.